In this section, we're going to be describing sets. So first of all, let's talk about what are sets. Well, a set is just a collection of objects. It could be a collection of letters or numbers or rocks or people or pets. It could be any sort of a collection of objects. And the individual objects that are inside of the set, those are called the elements or the members of the set. Whenever we write sets down on a piece of paper, like we have a standard way that we write these. So the first thing is the elements of the set should always be written inside of curly brackets. Those are called set brackets, those curly brackets. And we always use commas to separate the elements. The order that you put the elements in does not matter. So often we give sets names. I just decided to name this set A. So I have A equals, and then in curly brackets I have the numbers 1, 2, and 3. You can see they're separated with commas. So that's one way to write the set. Again, the order doesn't matter, so if I had written the sets in reverse order, or the elements in reverse order, 3, 2, 1, that's the exact same thing as 1, 2, 3. So it's redundant to change the order, so the order doesn't matter. Two symbols that you need to know. This little symbol, it sort of looks like an E a little bit. That symbol means is a member of. If you put a slash through it, it means it's not a member of. So we can talk about which elements are members of sets. So up here, I've got the numbers 1, 2, and 3 as the elements in set A. So I could say 1 is an element of set A. You could write it like that. A number that's not an element would be 4. We could say 4 is not an element of set A. So that's how we would write those. When you're listing the elements, you just write them down. You don't have to put them in any kind of brackets or anything. We're just talking about the elements. So 1 is an element of A, 4 is not an element of A. Let's look at another example. The set of vowels in the alphabet can be written as this set. Set V, I named it V for the vowels, is A, E, I, O, and U. You can see they're separated with commas and they've got curly brackets. So we can say that A is an element of V. You've got to learn how to say that in English. So A is an element of V, but F is not an element of V. So I've got it in symbols and I've also got it in words. A is a member of the set. F is not a member of the set. So in order for sets to be useful in math, they need to be what we call well-defined. So well-defined just means that there's no ambiguity about whether or not something would be an element of your set. Like it's defined specifically enough that we can all agree what belongs to the set. So if I say something like the set of odd numbers, most people know what odd means. That's a pretty specific thing. Like numbers are either even or they're odd. And if you ask somebody what are the set of odd numbers, they would probably start writing you a list like this, right? And it's a set, so we put it in curly brackets, but we know that it starts with 1. 1, 3, 5, 7. These are all of the odd numbers. So this one is what we would call well-defined, because odd is a specific enough word. How about the second one? It says the set of large dogs. Well, if you were going to list large dogs, which dogs would you list? Because I don't know about you, but what's maybe large to you is small to me, or vice versa. Or maybe what you think is a large dog is not actually considered really a large dog. So I think that word large is a little too ambiguous, and so I would say this set is not well defined, because we could kind of argue over which dogs would go in the set of large dogs. So I'll say large is too ambiguous.